Hello, everyone. So today I'm going to do two things. Firstly, I want to teach you guys about salts, and then at the end of that, I think I'm going to make another one based on some of the questions I'm getting from the review sheet of people that want to go through a few more of those things. So I will do that. But I first want to start with salts here. So salts are generally thought of as just some ionic compounds, and usually you think metal nonmetal or metal polyatomic ion or polyatomic ion nonmetal or polyatomic ion. There's like 4 different ways you could have a salt. What I like to do with salts is split them up into cation and anion, so plus minus. And all you do is you just split them up. And here's your easy rules. Okay, if you are a group 1 metal or calcium, strontium, or barium, they have a negligible effect on pH. Negligible effect on pH. So anything that shows up on this side that's a group 1 metal or those 3 things, it's going to be neutral. So like these would contribute to a neutral salt. Anything else, and this is going to sound kind of weird, anything else is going to be acidic. Now let me show you an example of this, because this is something you may have kind of run into in a few of the examples. This is a classic one. Is you might think like, all right, well that means aluminum. So Al plus 3Aq is actually considered an acidic cation. The reason why is Al plus 3 is actually so highly charged that it attracts water molecules to it. Approximately 6 water molecules. So you'll end up with like 6 water molecules around this aluminum. And the way you actually draw this ion in solution is going to sound kind of weird. It's so it's Al H2O6 plus 3, and then that hydrated aluminum ion is attached to 6 waters covalently, oddly enough, and then what happens is that aluminum is such a strong pull, has such a strong pull on electrons, that what it does is one of the H's actually comes off and protonates a water. So what ends up happening, this is going to look weird, prepare yourself for this one, Al H2O5OH plus 2, plus 2 AQ. Let me make that 2 plus. So the whole ion, this is like one big ion, and then plus H3O plus. So that's why anything other than these things, any metal that's dissolved is going to actually be an acidic ion. So we'll practice a few of these, but you'll be able to answer these questions so easily. Okay, the anion, and this is why you got to memorize your conjugate bases. You have to remember your strong acids. Your conjugate bases of strong, I think I called it CBSA on the review sheet. I've never used that acronym, but I was doing it so much. Conjugate bases of strong acids, and except HSO4 minus. So they're all negligible as well. They do nothing in solution. So anyways, these ones would be NO3 minus, Br minus, Cl minus, I minus, ClO4 minus, ClO3 minus. Ignore that one. That's kind of a weird one. So These are all neutral. And then anything else is basic, which you may have seen on the review sheet. It may make sense now that, oh, if it's not one of these ions and it's in like a NaF, for instance, like NaF, that's actually a basic salt, and you can actually figure out the pH pretty easily. So anything else is considered basic if it's not one of these things, except, now, there's a couple of, I'm not going to do it this right now this year, maybe later on in the year I'll show you this, but the math behind this is a little too complicated to explain in like a short video. So I'll just say HSO4, and I was talking about this yesterday. Note how the H is in here. That makes this ion amphiprotic, and it actually can act as an acid or a base, but it turns out that HSO4 minus is actually kind of like a pretty, well, it's a stronger weak acid. It's got a pretty low Ka, or a pretty high Ka. So HSO4 is acidic. That's probably the only exception you're going to see, especially on the SAT2. That's probably the only one you'll see is HSO4 minus, okay? All right, so let me give you some examples of these, and I'm probably going to use CBSA as like a nice, easy way of remembering, because I'll probably forget. It takes so long to write that. We'll just go through it with these rules. So I'll put up a few here. Let's do KCl, NH4, NO3, CAS, CA, HSO4, 2, and NaBr. I wonder if I have any room. Let me do one more up here too. I'll do it up here, just so you can kind of, go with these things here. So we'll do KNO2 and LiF. Okay. So KCl is going to be group 1 metal. So group 1 metals are neutral. So that will do nothing in solution. Cl minus is one of these CBSAs. It's the conjugate base of a strong acid. So that's also neutral. And therefore, neutral, this salt is neutral. Got it? NH4NO3. So not group 1, and it's not calcium, strontium, barium. So therefore, this one is acidic. And NO3 minus is over here. It's a CBSA. So that's a neutral. And together, those come up to be acidic. CAS. Ca, neutral. S, I'm just going to write neutral. S is not one of these. So this is basic. So CAS will be basic. CaHSO4, neutral, and then HSO4 was one of the ones I told you. Remember this one. This is the only one they'll usually ask on like the negative side that's going to be have an H. So this one is going to be acidic, and therefore neutral and acidic. This is an acidic ion, or acidic salt. NaBr. This one is neutral. Br minus is also neutral. So this salt will be neutral. Then go back up to here. K is neutral. It's a group 1 metal. NO2 minus is actually not one of these things. So this is going to be basic. So there is a basic salt. And LiF, Li is neutral because it's a group 1 metal. F is a basic because it's not one of these. And so this is a nice basic salt. I swear, like the 9 salts that I gave you, super easy to do. You'll have a chance to do these on the quiz. They're like easy points. Just kind of refer back to this chart and you got it, okay? I just wanted to show you one more thing. And I want to go back to this, like anything else is basic. And it's a great way to get, and this was a question from the review sheet, I think, or maybe from the notes that somebody was asking me. I think it was Viraj. So I'm gonna put up Viraj and no, this was Anya. Anya was asking me about the rationale behind Ka times Kb equals 1 times 10 to the negative 14th. So remember, this is for Anya's question. So if you're out there, Anya, this is for you. Also, Viraj and Kathy had alluded to this question as well. So the answer is actually pretty easy. Remember, these are conjugates of each other. So let's say I got some acid. We'll use HF. So I say HF plus H2O. So here's my acid. My Ka of this one is it's 6.8 times 10 to the negative 4th is the Ka of this acid. And then that gets you H3O plus F minus. And if I was going to mention the base, which would be the F minus, its conjugate base is F minus, and I added that to water. Sorry. What it would do was it would accept a proton, and so you'd end up with HF plus OH minus. And remember with Hess's law, with these things, you multiply the Kas and the Kb's of, like, whatever the K is of these reactions, if you're going to combine those two reactions. So if you combine reactions with equilibriums, so let's say K values, you multiply, this is on your last test, multiply the K's together. So if I did that, if I said, all right, well, I'm going to add these two reactions together, look what cancels. H2O, you don't really care because it's liquids. So, I mean, I'll just leave it there, but it doesn't really matter. Look what's left. So multiplying these would put this times this. So you'd end up with Ka times Kb equals H3O plus times OH minus. And at 25 degrees, you know that H3O plus and OH minus are 1 times 10 to the negative 14. So that's where that comes from, if you were looking for that. Okay. All right, so there'll be more coming today later. Bye, guys.